Ladies and gentlemen, I am John Pace, a member of the R.M. Santilli Foundation and the chairman of the World Lecture Series on Hadronic Mathematics, Mechanics, and Chemistry. It is a pleasure and honor for me to present Professor Ruggero Maria Santilli in delivering Lecture 1D, which is perhaps the most difficult lecture of this series, on the identification of the limitations of Einstein's gravitation and general relativity. I indicated previously the difficulties of the preceding lectures on the limitations of special relativity, quantum mechanics, and quantum chemistry. These difficulties are magnified for the case of general relativity due to the unfortunate suppression of a true scientific process in the field because serious technical objections published in refereed journals have been mostly ignored by researchers in the field for about 1 century, rather than accepting them or dismissing them also in refereed scientific journals. In fact, Professor Santilli has been the victim of rather serious obstructions by organized interests on Einstein's theories for over 30 years. These obstructions have been documented, reported, and denounced by the International Committee on Scientific Ethics and Accountability in their website www.scientificethics.org. No serious understanding of this lecture can be achieved, not even minimally, without first addressing basic issues of ethics and accountability by high-ranking members of the organized interests on Einstein's theories. In this important lecture, Professor Santilli reviews 3 groups of technical objections on Einstein's gravitation and general relativity. First, the historical objections published soon following the appearance of general relativity. Second, physical objections on Einstein's conception of gravity. And third, rather serious geometric incompatibilities of the field equations with the Freud identity of the Riemannian geometry, as well as the electromagnetic origin of the gravitational field. The understanding of this lecture additionally requires a technical knowledge of the new space-time symmetries presented in the lectures of Level 3 and their experimental verifications presented in the lectures of Level 5. Ladies and gentlemen, it is my distinct pleasure and honor to introduce Professor Santilli for the delivery of the most difficult and therefore the most important lecture of this series.
Ladies and gentlemen, as stated by our chairman, John Pace, this is the most difficult lecture of this series. So therefore, I had to select an appropriate location where to deliver this lecture. Let me state very bluntly that to deliver a lecture on the limitation of Einstein's general relativity in any qualified academic institution in the United States of America or most of Europe is totally outside reality, as it will be documented progressively throughout this lecture. So I had to select a receptive environment. Among a number of very receptive countries, such as Greece, that is very open to basic knowledge, I selected Egypt because of my attachment and my love of Egyptian ancient civilization. You may have seen the view of the Luxor temple in the introductory part. However, look at the date. This is January 29. We initiated the lecture jointly with the initiation of the Egyptian Revolution. And indeed, the Luxor temple was empty, as you may have seen, while in reality it's full of thousands and thousands of tourists. The reason it was empty because there were military tanks patrolling the streets nearby. To make a long story short, we were evacuated by the Belgian government because our flight originated from Brussels. We were treated by the Belgian government with white gloves and 5-star hotels and things like that. I want to say thanks to the Belgian government. It was really a privilege to be part of their action. But as a result of all this, the lecture had to be restarted and we had to redo completely in the United States of America, and in particular in Florida. Well, let me begin by stating the obvious. Albert Einstein has entered in the history of science for many reasons. An additional reason is that he has been the first to initiate a geometric study of gravitation. Additionally, he selected a geometry, the Riemannian geometry, which is simply fascinating, and this has a mathematical beauty that is undeniable, as proven by the fact that Einstein's general relativity and gravitation have attracted a large number of pure mathematicians, applied mathematicians, and theoretical physicists, including myself. And this has been going on for close to a century, 96 years to be exact. After having said so, I have to make a blunt statement. After studying for 50 years the consistency and the various aspects of general relativity and in general, and Einstein's conception of gravitation in particular, my conclusion is that those theories are fundamentally flawed, and they have an unresolvable basic inconsistency, insufficiency, and shortcomings. I've tried for years to resolve the problems that we will be addressing during this lecture and fail. You reach a point in which we have, as a scientist, we have to admit the truth to the best of our knowledge. Okay, at that point, as is also known, I have been dubbed with all sorts of names this, what I'm about to say is fringe science and so on. There was also an editor when I published papers of appraising the limitations of Einstein's general relativity. There was an editor, I have never heard his name, who felt compelled to send long email all over the academic world, claiming Santilli is a nuclear physicist. Of course, I've written a number of papers in nuclear physics, but I'm an applied mathematician. And then the theorems that you will see in a moment, in a few moments, the theorems were disproved by a tangential epistemological and philosophical aspect. So let me make another blunt statement to people such as these unmentionable editors. I have been, for several years, a member of the Department of Mathematics of Harvard University under several grants from the Department of Energy. Therefore, I am fully qualified to express a judgment on the Riemannian geometry as well as on general relativity and Einstein's conception of gravitation. Needless to say, I'm not expecting you to agree. This is not the issue. It's a question that I am sufficiently qualified, so therefore my objection, published in an independent, severely refereed journal, should be considered if we don't want to pass the boundary from science into politics. Very well. Let's begin with an analysis of the most fundamental insufficiency. Those are not inconsistencies, insufficiency and of Einstein's general relativity. The first one is that after 1 century of attempt in the river of public money, it has been impossible to identify a consistent quantum version of gravitation. We now know the technical reason for, because the Riemannian geometry is necessarily a non-canonical instruction, since it is a deformation of the Minkowski geometry. So therefore, any operator image of Einstein gravitation must necessarily be non-unitary. The non-unitary quantum theories are known to be catastrophically inconsistent when formulated with the mathematics of unitary theory, Hilbert spaces, etc. This catastrophic inconsistency are studied in details in lecture 2A, 2B, 3C, etc. So there's no point in reviewing them here. Nevertheless, this has been a major loss to science, namely the absence of at least an operator form of gravity. It is a major insufficiency that has to be kept in mind by physicists an observer in good faith. The next insufficiency is that also after close to a century of attempts, in reality were initiated by Albert Einstein himself, general relativity has prohibited any consistent grand unification of electroweak and gravitational interactions. We know nowadays that by following the historical conception of gravitation by Einstein, there is no hope whatsoever of achieving a consistent grand unification for many, many reasons. Just to flash a couple, the electroweak interactions are a magnificent theory verifying a symmetry, a universal symmetry, the Poincare symmetry. Gravitation has no symmetry, has a covariance. The moment you match a covariant theory with Poincare invariant theory, ladies and gentlemen, you have an horrendous minestrone that the outcome can only be catastrophically inconsistent. Also, the mixing of a theory formulated on a curved space, which is non-unitary, matched with the theory which is beautifully formulated on Minkowski space, you end up with another minestrone which has no chance of, no realistic chances of success. The reason, technical reason for the failure actually is an impossibility of achieving a consistent, there are all sorts of political grand unified theory, but one that really can resist the test of time. It's impossible, and we know many technical reasons. Additional reason for fundamental limitation of Einstein gravitation is the complete absence of any even a possibility of formulating the gravitational field of antimatter. The reason is known, but not spoken in the best PhD courses, whether in Cambridge, USA, or in Cambridge, England. And the reason that the only conjugation in Einstein gravitation is that for the charge. But bodies, astrophysical bodies have to be assumed generally to be chargeless, to be neutral. Assuming they have a little charge, the contribution of little charge to the gravitational fields of a massive star, antimatter star, is zero, virtually zero. So therefore, it is an intrinsic insufficiency of the theory. Those problems have been addressed. I spent many decades of my life to try to attempt the resolution of those processes, of those insufficiency. I did achieve a preliminary solution, but I had to depart from Einstein gravitation. This is presented in this monograph, which has been published by Springer, one of the best publishers, scientific publisher of these days, and because I'm on the continuous accusation by equivocal scientists in gravitation until he published his idea in a journal in which he is the editor-in-chief. This is not the case. That's more, before accepting this monograph, Springer studied, submitted to referee in 3 continents, and it was accepted with no modification. The study of this monograph, which is available as a free PDF download because no longer available in the original printed form, I believe is necessary for an understanding of the rest of this lecture. Very well, I have divided this lecture into 5 parts that deals with more detailed critical examination of Einstein's general relativity and gravitation. The first, incidentally, all those objections that I am presenting are unresolved. Namely, they've been published in referee journals, a variety of referee journals, by a variety of authors, not only by myself, but all they remain totally ignored by the so-called establishment in gravitation. Therefore, creating very serious problem of scientific ethics and accountability that must be addressed if we really care about our country and if we care about knowledge. It should be always be kept in mind that this manipulation of science, such as complete ignorance of inconsistency by other scientists in the fields, this type of equivocal scientific acts are perpetrated under public support by United States taxpayers. So therefore, the last section indeed is dedicated to a clear addressing of these ethical issues in the field without which the consideration of basic insufficiency of Einstein gravitation will just be a farce, ladies and gentlemen. It will not absolutely be, not worth even the consideration. I always stated in my writing that no basic issue in science could be nowadays considered unless we consider jointly issue pertaining to scientific ethics and accountability, for reasons that will be clear during this lecture. So the first unresolved issue that I want to bring to your attention are, I call them historical character. They appeared immediately after the proposal by Albert Einstein of his theory of gravitation. Then in the middle of the past century there were additional unresolved, unaddressed insufficiency, actually inconsistency of physical character. And then there were additional inconsistency of geometrical character more recently. And then finally there has been theorems of inapplicability of Einstein gravitation for interior gravitation that have established this point beyond any possible doubt or any credible doubt. Very well, let's start with part one. The original historical unaddressed and unresolved insufficiency or inconsistency, if you want. The first one relates to the bending of light, which was the birth of Einstein gravitation, as we all know. This is a pictorial view of the idea of the bending, and this is one of the consequences, the so-called lens effect. The first issue that we have to address here is the bending of light real or not? Does it exist in reality or not? The answer is absolutely yes. The existence of the bending of light is beyond any doubt. Here is just two of a large variety of evidence. Here you can see is an astrophysical object. In the back there is a star, but we don't see the star. This halo of light means that there has been a bending of light from the back to us. We can observe also this bending at sunrise and sunset. In any case, it is a visual. It's a visual evidence. This is the verification of the halo due to the lensing effect. Very well. So the issue is now, how do we interpret this physical evidence? Now, as you know, Einstein proposed the interpretation of this phenomenon by the curvature of space. He essentially said that this bending of light is evidence that space is actually curved. And then since space is actually curved, so Einstein said, then we need a geometry that represents curvature as a necessary condition to represent the bending, and therefore among all the geometry he selected Riemannian geometry. This process is well known. What are the historical objections that are unresolved? The first historical objection is that the bending of light is entirely of Newtonian character, to such an extent that there is no need whatsoever of introducing curvature for the representation of the bending of light. So the argument is essentially the following, that Newtonian gravitation is universal, is admitted by everybody to be universal. Once you admit that Newtonian gravitation is universal, you must also admit that it attracts light. If for some reason the light escapes Newtonian attraction, ladies and gentlemen, we have to rewrite 4 centuries of science since the beginning with the historical script by Newton. Now, people say, oh, Dr. Santilli does not understand gravitation. That's what they normally do, because they don't have a technical argument, so they go into this step. So, and what they say is ludicrous, because they say, oh, but Newtonian attraction is expressed in terms of masses, and light has no mass. Since the light has no mass, they say, therefore is not attracted, but is not part of Newtonian attraction. And this type of objection, when proffered by experts, they are indication of a very equivocal posturing. Why? Because it is well known by experts to qualify as such that the origin of the gravitational field is the energy and not the mass. Indeed, there is no mass momentum tensor. It doesn't exist. What the tensor exists is the energy momentum tensor. And that is the source of the gravitational fields in any decent level of treatment. So therefore, since the energy is the origin of the gravitational field, is part of the mechanism of attraction, I have always written Newton's equation in their identical form, no change whatsoever, in which I write the energy instead of the masses, and I rescale the gravitational constant. This is an identical reformulation. But then the representation of the bending of light is trivial, because one of the two energies says the rest energy of Jupiter, and the other is the energy of a light beam, as you know, as everybody knows, H nu, namely according to Einstein formula. So this point is this objection is very, very serious, because it goes at the very, very root of the conception of gravity as being characterized by an actual curvature of space, because it's established that there is no need of an actual, at least this is a very consistent treatment. It represents numerically the experimental evidence without curvature, actual curvature of space. As such, if we ignore it, ladies and gentlemen, we exit from science and we enter into politics. I'm not claiming necessarily that this argument is correct. Maybe it has some flaw on its own. That's not the point. The point is the suppression of debating this historical objection. So I challenge my colleagues at Princeton University, or at Cambridge, USA, or at Cambridge, England, to debate whether this is correct or false. And I challenge them jointly with the debate of other aspects that they will see. If they do not want to debate, then I recommend them not to use public funds from the American taxpayer for personal theologies, because that will be a violation of our law, will be abuse of public funds. It's just that simple. Now, let's see what happens with the representation, with Einstein representation of the curvature of space. Ladies and gentlemen, it is based on a chain of assumptions. There are 7 independent assumptions to achieve indeed, and then after 7 assumptions, you do indeed achieve a representation of the bending of light with the curvature. Yes, you do at the end. But the problem is that each and every one of those assumptions is debatable, as you will see in the rest of this lecture. Let's start with the first assumption. Those are the basic equation of Einstein gravitation, representing the very essence of his conception of gravitation, namely the reduction of gravitation to pure curvature with no sources. Look at here on the right hand side, there is 0. And now immediately at this point, the equivocal physicist will say, oh, this Santilli does not understand, does not know that you can put on the right hand side, there are also source tensor on the right hand side when the body is charged. Ladies and gentlemen, when that objection is moved, it's equivocal. It's equivocal, because Einstein was Einstein. This we are talking about, for instance, the gravitational fields of the sun, that has an enormous mass. The source tensor on the right hand side is for the potential charge of the sun. Let's assume that the sun is indeed charged and we can measure. But then, ladies and gentlemen, the contribution of the charge to the gravitational field of the sun is 10 to the minus 40. It's 0.0040 before you see a contribution. Just mentioning that there are in this argument that there are source terms due to the charge is corruption. Either it's total lack of any technical knowledge or it's corruption. This is what Einstein stated. The point, however, is that these equations are irreconcilably incompatible with the electromagnetic origin of the mass, demanding a first order, not 1 or 10 to the minus 40, a first order source tensor on the right hand side, as we will see in part 2. So the very basic assumption is fundamentally flawed. and has not yet survived the test of time. But then you go to all the others. Then you have to select, a metric. This is you have a large variety. Look at this. It's even in contradiction with the Schwarzschild metric. It's just selected a lot among a large variety. And rather than this, I want to select another solution. And then with covariance, you have an infinite variety of line element you can select. And then after that, you have to select the geodesic. And then after that, you have to select this and this and that. After that, yes, indeed. After that, you represent curvature. But ladies and gentlemen, let's compare the power of the representation of the bending of light by Newtonian gravitation with this chain of assumption. There's no question in my mind that Newtonian representation is preferable, because there is no assumption whatsoever. Everything is based on first principle without assumption. At this moment, the correct question is then why do we have to use curvature when Newton represents indeed exactly the experimental evidence of the bending of light? Immediately we'll say, oh, because there is the 45 seconds of the perihelion Mercurium and other things. Ladies and gentlemen, but we don't have to represent 45 seconds of perihelion. We have to introduce all sorts of a chain of continuous assumption and counter-assumption, each of which is debatable and actually has been disproved. And in any case, the 45 seconds of perihelion and other aspects have been represented by theories in a Minkowski space, with an abyssal difference with the representation with Riemann, as we will see. Representation of those relativistic effects in Minkowski space without curvature is invariant over time, because it possesses the Poincare symmetry. This has no invariance, it's a covariance. So the numerical prediction of 45 seconds is only a Polaroid picture, as we will see in a moment. In conclusion, I have to conclude, to the best of my knowledge, that the Newtonian gravitation is preferable to Einstein gravitation, to the best of my knowledge, at this first stage. But let's keep going. Another historical objection, also totally unaddressed, is that the curvature positively cannot allow the representation of a fundamental event in gravitation, which is the free fall. The free fall of an object along a straight radial line. Here is the Tower of Pisa. Galileo went on the top. Of course, there was an historical test for not for gravitation, but well, for the gravitational constant. But in any case, already since Galileo, we can see the straight character. There is no possibility, ladies and gentlemen, to represent this event with the curved space. None. And at this point, immediately they tell, oh, but no, but we go into the geodesic, which is a radial line. Sure, but then, of course you do. But then you have to kill the curvature tensor. So you have to annul the curvature, which is precisely the objection. So this objection has to be matched with the preceding one that essentially established the profound doubts on the fact whether space is indeed actually curved. In other words, it may be possible that the Riemannian geometry, due to its magnificent beauty, can indeed represent gravitation in a very elegant way. But the fundamental point persists, is that it does not necessarily mean that the space is actually curved. Even though the representation is magnificent from a mathematical viewpoint, it does not mean that space is actually curved. Think in this way. Not only the bending of light, but the idea of a curvature is associated with the trajectory of planets around the sun. But that associating this trajectory with the curvature, ladies and gentlemen, is fundamentally flawed on any grounds and serious scientific grounds. That's basically Newtonian trajectory of equilibrium between the gravitational attraction and the centrifugal force due to rotation, positively, absolutely without any curvature of space whatsoever. Let's go to the next objection, the third out of a number of historical objections. I've selected only three. Namely, The fact that we have a weight. Look at me. I'm heavy. See, I'm attracted by the earth. And I feel this weight without moving. Without moving. Now, what is the problem? So what is the historical objection? Einstein gravitation cannot represent the weight of stationary bodies. This is essentially the objection, while Newtonian gravitation can. Ladies and gentlemen, I meditated on this for decades. I have to agree with the historical objection, and I found no possibility to represent this fundamental third additional gravitational point with Einstein gravitation. Now, again, it may well be that my knowledge is insufficient. It may well be that Einstein gravitation represents the phenomenon. Yes, this is not the issue at stake here. The issue which is at stake is the unaddressed, unresolved, which means a profound disease, profound ethical problems in the entire scientific community on gravitation for one century, with the abuse of a river of money from the US taxpayer and taxpayers from other countries. The conclusion is that, to the best of my knowledge, in regards to those fundamental events, I have to prefer Newtonian gravitation to Einstein gravitation. At best, if there is need of correction, definitely I will prefer relativistic corrections, namely corrections or enlargement or formulation of gravity in the Minkowski space and not in the Riemannian space, for a variety of technical reasons that you will see throughout this lecture. Most importantly, the lack of an invariance. Minkowski gives you Poincaré. The number that you predict are invariant under the time evolution. With Riemann, you have covariance, which by very definition, the numbers that you predict are not preserved in time. So therefore, ladies and gentlemen, if I remain as being a physicist, I have to select the most plausible approach to the best of my knowledge and to the best of my capability. And that is abandoning the Riemannian formulation of gravity in favor of relativistic extension of the Newtonian gravitation, with understanding that Newtonian gravitation already represents the virtual entirety, except for small relativistic corrections. But let's see the implications of the lack of addressing of those issues. They are very serious. Whenever fundamental aspects in science are not resolved, are not even debated because of purely political manipulation of the status of science, which is the preferable condition, then there are consequences. Gravitation is at the end of directly or indirectly affect the entire knowledge. We're talking about Newton, and we're talking about the foundation of our knowledge. This one is unbelievable at first sight, namely that the masses of all planets and the mass of the sun are unknown on strict scientific grounds at this moment. Even myself, I do not know how to compute them. I repeat, it seems paradoxical that we do not know the masses of Jupiter, of the Earth, of the Sun, Mars, etc. Well, let's listen to the argument first, and then throw judgment after the technical knowledge. But this you have to study some new mathematics to understand deeply this issue. Again, you have to remember that the source of the gravitational field is not the mass. Mass is a parameter that we throw into the equation to express our ignorance. What is a mass? We don't know. So the source of the gravitational field is the energy. So Newton's equations have to be written to be correct the way I've been doing for decades in terms of the energy. Number one. Number two, the trajectories of the planets in our solar system are known with extreme accuracy. They've been known with great accuracy since the Mayan and the Egyptian times. Now, what does this mean? This means that out of the extremely precise knowledge of the trajectory, we know the energies, the total energy of all the constituents of the solar planet with extreme accuracy. We know the total energy of the Earth, the total energy Sun, etc., etc. How do we go from this to the mass? Through the equivalence principle, of course. But here is the point. The equivalent principle was formulated by Albert Einstein and confirmed experimentally for point particles moving in vacuum. Point particles moving in vacuum, under which assumption, indeed, it is exactly valid. But the expansion, the extension of the same equivalence principle to a large body such as Jupiter or the Sun is a pure personal belief at this moment without any experimental evidence of support. For many, many reasons that we will study throughout these lectures. Some of them are already studied in lecture 3a. For instance, if we assume that this equivalence extends also to Jupiter, this automatically implies that in the interior of Jupiter, the speed of light in vacuum is also the maximal causal speed. In other words, we have to necessarily assume that the maximal causal speed in the core of Jupiter is the same as that for a point particle in vacuum. This is a personal belief, just pure theology. It may be right, may be wrong. We do not know. We have to be careful if we want to be serious in science and separate what has been established and what is a personal belief. This is one of them. The extension of the equivalence principle to macroscopic body, especially large body, is unknown at this right. As a matter of fact, this issue is at the foundation of the conjecture of the dark energy, because dark energy is a consequence for the intentional intent of maintaining the validity of the equivalent principle also for a black hole. But this implies that the maximal causal speed inside a black hole is the same as the speed of light in vacuum. We pass all boundary of logic, of credibility, of serious behavior. In the interior of a black hole, we don't know what the maximal causal speed is, but then we don't know the equivalence energy of that black hole. Once you accept deviation for large objects only from Einstein's equivalence principle, as done by the isotopy, isorelativity in lecture 3a, 3b, and 3c, then you instantly remove any need of dark energy in the universe, and they have all sorts of additional implications.